हाय डियर स्टूडेंट्स, अगर आप इन वीडियो लेक्चर्स का मैक्सिमम यूटिलाइजेशन करना चाहते हो तो आई थिंक आपको ये इंप्रूव सेशन डेफिनेटली फॉलो करना चाहिए और रिलीजियसली फॉलो करना चाहिए। इंप्रूव सेशन क्या है, इसका लिंक डिस्क्रिप्शन बॉक्स में है, तो जाओ उसको चेक करो। इसके अलावा अगर आप व्हाट्सएप ग्रुप ज्वाइन करना चाहते हो, और मुझे लगता है आपको करना भी चाहिए, तो आप क्या करो, हमारे वेबसाइट पे जाकर के अपने कॉन्टैक्ट डिटेल्स दे दो, या फिर इस व्हाट्सएप नंबर पे जाकर के अपने कॉन्टैक्ट डिटेल्स दे दो, सो दैट हम आपको उसमें ऐड कर सके। चलो अब पढ़ना शुरू करते हैं।
Hi, welcome back. This is a problem solving session in friction where we will be discussing the archives problem, and this also happens to be your assignment. Okay, so let's start. A horizontal force of 10 Newton is necessary to just hold a block stationary against a wall. The coefficient of friction between the block and the wall is 0.2. The weight of the block is, so they are saying just hold the block. So in this case the maximum friction is going to act. Okay, so this is 10 Newton. Okay, let me just, okay, so this is 10 Newton, and here is going to be my normal reaction. This is my weight mg, and this has to be my frictional force. In this case the maximum friction is going to act. Okay, so maximum friction is nu into n, and so this F is balancing this mg, this 10 Newton is balancing this n, so n becomes 10, and nu is 0.2, so nu into n, that is the maximum friction force. So the maximum friction here is F max 0.2 into n, so this is nu into n, and n is 10, so this becomes 2 Newton. So maximum friction is acting, and that is balancing the weight, so weight also becomes 2 Newton. Okay, next question. A marble block of mass 2 kg lying on ice when given a velocity of 6 meters per second is stopped by friction in 10 seconds. Then the coefficient of friction is, so let's quickly draw the diagram. The mass is given as 2 kg and lying on ice when given a velocity of 6 meters per second. So initial velocity is 6 meters per second and stopped by friction in 10 seconds. So this guy given a velocity of 6 meters per second stops after 10 seconds. Then the coefficient of friction is, so obviously that acceleration is going to be maximum acceleration because the sliding is there, and that maximum acceleration is coming from the maximum friction and it's acting backwards. So this A is equal to nu into g, so it's actually retardation. Okay, so the friction, like time is given as 10 seconds, so final velocity is 0, initial velocity is 6, and the body stops after 10 seconds. So you can use v is equal to u plus 80. Okay, so v is equal to u plus 80, final velocity 0, initial 6, and A is going to be nu into g, so it's negative, so minus nu into g into t is 10. So from here you can calculate that nu is 6 by 100. Okay, because g is also 10 and this is 10, so 10 into 10 100, nu is equal to 6 by 100, that is 0.06. okay, so the answer is D. Okay, moving on to the next set of problems. A block rests on a rough inclined plane making an angle 30 with the horizontal. The coefficient of static friction between the block and the plane is 0.8. If the frictional force on the block is 10 Newton, the mass of the block is, okay, so let's quickly draw the figure. Okay, so here it's given that suppose the mass is m and the coefficient of static friction between the block and the plane is 0.8. okay, if the frictional force on the block is 10 Newton, find the mass of the block. Okay, so let's quickly calculate the maximum frictional force. If m is given, then this is going to be my mg, and this is mg cos theta, assuming this is theta, this will be my n, downward is going to be my mg sin theta, and friction is going to be acting upwards. Okay, so the condition given is that block is at rest. Okay, so if the block is at rest, see, I can calculate the maximum frictional force. In this case F max is going to be nu mg cos theta, that is basically nu into n, but this is at rest, that means your mg sin theta, the horizontal force is balanced by the vertical force, that is F. Okay, so in this case you don't have to even calculate the maximum frictional force. In this case mg sin theta is going to be equal to F. Okay, so the value of mg sin theta is going to be mg sin theta is equal to your frictional force. Friction is acting, is given as 10, so mg sin theta becomes 10. Mg sin theta becomes 10, that means m becomes like 10 by g sine theta. So m is f by g sine theta. F is 10, g is 10, and this sine theta. Okay, so 10 cancel out. M is sine theta. Sine 30 is 1 by 2, so m becomes 2 kg. Okay, so this is the answer C. Let's move on to the next problem. A smooth block is released at rest on an 45-degree incline. Okay, and then it slides a distance d, and the time taken to slide is n times as much to slide on a rough incline than on a smooth incline. The coefficient of friction is. Okay, so it's given that if this is smooth and this is friction, so assuming both angle is theta, okay, the coefficient of friction, so this theta has to be same in both cases. The time taken in this case, suppose this is nu equal to 0, and in this case some nu is given. Okay, so the time taken to go from here to here in this case is n times time taken to go from here to here. So in this case the acceleration down the plane is going to be g sine theta, and in this case the acceleration down the plane is going to be g sine theta minus nu g cos theta. Why? Because in this case the downward force is just mg sine theta divided by m is going to be g sine theta. In this case the downward force is going to be mg sine theta minus the upward force is nu mg cos theta. If the guy has to slide, then there has to be maximum friction, and that is nu into n. N is mg cos theta. From this previous calculation you can see that. So this acceleration is going to be mm cancels out, so acceleration is going to be g sine theta minus nu g cos theta. Okay, so let's calculate the time in this case. So suppose the distance is d, so s is equal to ut goes to 0 because initial velocity is taken to be 0. Ut s is equal to ut half into a. I'm just going to call this as a1 and this as a2 half into a1 into t1 square. Okay, and in the second case d is equal to half into a2 into t2 square. It's also given as the time taken to slide is n times as much to slide on a rough inclined surface than on a smooth inclined surface. So this time t2 is n times t1. Okay, so t2 is n times t1. Just put the value of t2 is equal to n times t1 and equate both sides and you'll get your answer. Okay, okay, so here's the calculation. I'm going to equate both sides. So half into a1 into t1 square is half into a2 into t2 square. So half of gets cancelled out, and again I'm going to write t2 is equal to n times t1. So just solving and cancelling this g value and then cancelling this t1 value because this t2 is n times t1. So t2 square is n square, t1 square. This cancels out, and then again just put the value of sin theta and cos theta and you'll get your answer. Okay, let's move on to the next set of problems. Okay, in this problem they're saying the upper half of an inclined plane with inclination phi, so this is phi, is perfectly smooth while the lower half is rough. A body starting from rest at top will again come to rest at the bottom if the coefficient of friction for the lower half is given by. Okay, so let's say this distance is s and this distance is also s, since it's equal, and the body starting from here, it will attain some velocity here and then beyond this, and they're saying this is going to be at rest. So beyond this point the body is actually retarding. Okay, so the maximum friction is more than the mg sin theta value. Okay, so when the body is coming from here to here, let's call this point A, this point B, and this point C. Okay, so the distance traveled is same in both cases, so I'm going to equate the distances, and s, like in this case s is equal to ut plus half at square. No, maybe I'm just using v square is equal to u square plus 2s because I can use this path velocity for this calculation. Okay, so we'll be using like the equation of the distances. I'm going to write this distance is equal to this distance. So again, coming from A to B, let's say velocity at this point is v, so I can write v square is equal to u square, u is 0, 2 into a, 2g, g sin theta is going to be the acceleration, 2g into s. Okay, so in this equation I'm going to get v square by s is equal to 2g sin theta. Okay, or just sine phi because this is phi, so I've written theta, so I'm going to continue with that value. Just make it clear that theta is equal to phi. Okay, Okay, again from B to C, I know at this point velocity is again 0, so again v square is equal to u square into 2 into a into s, so v square is equal to u square plus 2 into a into s. This value is 0 and this u square is this v square, so v square, and then again acceleration is actually this body is slowing down, so the acceleration is upward, and that acceleration you're going to write at a negative value, so that acceleration is minus, and this is going to be nu g cos theta minus g sine theta, because you're going to talk about the maximum frictional force. Maximum frictional force upward is going to be nu into m into g cos theta, and the downward force is mg sine theta. So the net force upward, like, is in the upward direction, that is nu mg cos theta minus mg sine theta divided by m is going to give you the acceleration nu g cos theta minus g sine theta. Okay, so v square is equal to u square minus 2 into a into s. So from this calculation, v square by s is going to give you 2 nu g cos theta minus g sine theta. Okay, so just equate both equation in both sides, so this 2 and 2 gets cancelled out, and again g cancel out, so you're going to get sine theta is equal to nu cos theta minus sine theta. So what you're going to get, sine theta is equal to nu cos theta minus sine theta. Keep in mind this 2 gets cancelled out, and again this g also gets cancelled out, so this becomes 2 sine theta is equal to nu cos theta, or nu is equal to 2 tan theta or 2 tan phi. Okay, so this is the answer. Let's move on to the next problem. A block of mass m is placed on a surface with a vertical cross section given by y is equal to x cubed by 6. Okay, so if the coefficient of friction is 0.5, the maximum height above the ground at which the block can be placed without slipping is. Okay, so in this case there are you just make a diagram, simple diagram, and it's going to give you the answer. It's very easy. Just surface with a vertical cross section given by y is equal to x cube. So that surface is not a straight line, is some kind of curve. Okay, and that curve equation is given by y is equal to x cube by 6. Okay, the coefficient of friction is 0.5, the maximum height above the ground at which the block can be placed without slipping. Again, and the maximum height, and that means they are going to correspond to the maximum downward force, or correspondingly the minimum frictional force. Okay, so limiting friction is going to act. So suppose that angle at like the point at which they're going to place, if I'm going to draw a tangent, that tangent makes an angle, suppose theta. Okay, and here is my mass, this is my mg, this is mg cos theta, this will be mg sine theta, again normal, and this is my friction force. So if this block has to stay at rest, that this n is going to balance my mg cos theta, and this mg sine theta is going to balance my frictional force. Okay, so maximum frictional force is acting because they're talking about the maximum height. Think about it. If y is equal to x cube by 6, okay, y is equal to x cube by 6, this dy by dx is 3x square by 6, or this is like x square by 2. Okay, so the slope is increasing if my x value is increasing, so there is a limit, or slope is basically the tan theta, so there's a limit to which I can increase this tan theta, and after which is going to slide. Okay, so in this case I'm just going to write f max is nu mg cos theta and is equal to mg sine theta, the downward force. Okay, so this is going to give me tan theta is equal to nu. Okay, and tan theta, if you think about it, is nothing but this 3x square by 6, because y is x cube by 6, the derivative is my tan theta at any angle. So this is 3x square by 6 x square by 2. So I want the tan theta to be equal to nu. Okay, so x square by 2 is equal to nu, that is 0.5, so x square is 10. Okay, x square is 10, and if this value is not 10, x square is 0.5 into 1, x square is 1, so x is equal to 1. Okay, so x is equal to 1, and they want the value of the y. So if x is equal to 1, you just plug in the value and the value of x in this y equation, and that y corresponding becomes 1 by 6. Okay, Okay, moving on. Given in the figure are two blocks A and B of weight 20 newtons and 100 newton respectively. These are being pressed against a wall by a force F as shown. So this force is unknown. Okay, and if the coefficient of friction between the blocks is 0.1 here, and between the block and B and the wall is 0.15, the frictional force applied by the wall on block B is. Okay, now if I'm going to talk about the equilibrium of this guy, okay, think about nothing is mentioned in this case whether they are in equilibrium or not, but like if they're not in equilibrium, I can always increase the value of F so that the normal reaction is going to increase and the corresponding frictions are going to increase and the system can be kept at rest. So like nothing is mentioned, I'm going to assume that these guys are in equilibrium. That means the system is at rest, it's not moving in any direction. Okay, so if the system is not moving vertically, I can take this whole thing as a combined system. Okay, now taking as a combined system this A plus B, now these friction forces are going to cancel each other out and we have the weights. This is 20, this is 100, and if the system as a whole is in equilibrium, the force of friction on the block B has to be upward, F. Okay, this is F, and again this is in equilibrium, so applying the vertical equilibrium, this F has to be 100 plus 20 or 120 newtons. So this directly gives you the answer 120. Now if you want to analyze the system like a little bit more, like what are the forces, frictional forces like on each of the block, and what are the frictional forces here and here. Now think about it, this mass A is in equilibrium. Okay, so we have this 20 newton downward. Okay, so this mass is in equilibrium, that means upward friction force has to be 20. Okay, so if this is 20, then this is also 20 because this is coming as a reaction of the frictional force from the first guy, and we already have this mass 100. Okay, so if this is 20, this is 100, again this frictional force has to be 120 newton. Okay, so I hope this made sense. Let's move on to the next set of problems. Okay, this is the last problem, and this is not entirely related to friction because this is also going to include some work energy theorem concept. So I'm just going to like explain it like lightly, and once you're done with the work energy theorem or work power energy chapter, then again you can come back to this problem and see how I'm solving it. Okay, so it's given a particle is being released from this point P, it goes down like down the plane, and then again it goes to R, again releasing from rest at point P, and like again it goes to like it comes to rest at point R. Okay, and that given that the point P is at a height of 2 meter and this R is at a distance of x from Q, so this QR is the distance x, and they have asked you to find the value of nu and the distance x. Okay, given the condition, the particle is released from rest from the point P and it comes to rest at point R. The energies lost by the ball over the parts PQ and QR are equal to each other. Okay, and no energy is lost when the particle changes from direction from PQ to QR. Okay, so if they are saying loss in energy, in this case loss in energy, that means they're talking about loss in mechanical energy. Okay, and losses energy is only going to happen if it's going to happen in this case by the work done of the friction. Okay, so it's given that the loss in energy, the energy lost by the ball over the parts PQ and QR of the track are equal to each other. So this means that work done by friction coming from point A to point B is equal to point B to point C, or in the figure coming from point P to Q is equal to going from point Q to R. Okay, so in this case, let's say if I'm going from point A to point B, this work done by friction in this part is going to be nu mg cos theta into h by sin theta. Why? Because the friction force is going to be nu mg cos theta, the maximum friction force is going to act, and this distance, if this is h and this is theta, this is going to be h by sin theta. So this work done is the work done from A to B in the diagram. Okay, again going from B to C, there's no theta, so this work done is my work done from B to C. Again it's actually negative, so since it's going to be negative for both sides, so I'm going to cancel it, and solving this you're going to get a relation h is equal to x tan theta. Okay, so and or you can write x is equal to h by tan theta, and everything is known, this h is known, this theta is known, so you're going to calculate the value of x, and that comes out to be 2 root 3 or 3.46. Okay, and again, and since at point C the body goes to comes to it, comes at rest, so the body is going to attain some velocity at point B, and then again retardation goes to C and goes to 0. So what I can use, using work energy theorem, this kinetic energy of the body at point B, I can write half mv square. The change in kinetic energy is the net work done on the system, on the body. So the work done by gravity is mgh, and the work done by friction is minus nu mg cos theta into h by sin theta. Again, and for, this is for A to B part, and then for B to C part, I know V square is equal to U square minus 2 into A into S. Okay, so actually no, this B to C is here. This again is second calculation. So this equation is given. I am going to multiply by 2 both sides, and I'll get this relation: V square is equal to 2 gh minus 2 nu gh h by tan theta, and that can be written as this way. Okay. Again, for B to C, the final velocity is going to be 0, so I can write V square is equal to U square minus 2s. So U square is basically this value, whatever I got, 2gh minus 2 nu g x, okay, and minus 2 into A into x. Okay, so here, so this is going to give me 2gh is equal to 4 nu g x, and from here I can calculate the value of x. X is h by 2 nu, and nu is going to be h by 2x. So everything is known, h is known, x is known. I can put the value, I'll get 0.288. Pause the video if you want to let it sink in, and if this does not make any sense, don't worry, just go and see the work energy theorem videos, and then come back to this problem. It will make complete sense. Okay, so this I'm getting 3.46, and this I'm getting 0.288, and that is basically this answer A. Okay, so this concludes our friction problems, assignment problems. Okay, I'll see you in the next video.